Good morning, everyone. I hope you are all doing very well. I am hyped as well, Darkman. I'm glad that you are too. This is a very exciting update, in my opinion. This is something that has been a very, very long time coming, and I'm super excited about what I'm about to show you. It's very fun. So let's get right into it. This is the ROS 2 Revolution, and if anyone here is familiar with ROS, you are very well aware of what this means for the project. This is big, I think. But before we get into anything too recent, I want to cover some housekeeping from last week, where I mentioned that I don't have an analytic solution to the inverse kinematics for the hand. Don't worry if this doesn't make any sense. This doesn't really matter for today's live stream. But I just want to say that there have been two people who have submitted, well, not submitted, but like made me aware of some options for an analytic solution for this. But unfortunately, I haven't had time to check them out yet. I've been very focused on ROS and trying to get ROS to work, and I haven't had enough time to look at your solutions for this. But trust me when I say that I remember them, and like I don't remember the process, but I remember how to find what you wrote, and I fully intend to inspect those solutions further soon. Just not yet. I'm just a bit busy right now. And I really appreciate you taking the time to try to come up with a solution for this. It's very cool. I really like that. All right, so to cover what ROS is trying to do, or what ROS is doing for my project, it's worth just recalling that we had this structure from last week. This is how I was planning on already like setting up all of my code for the current instantiation of Jugglebot. And this was cool, but there were some problems with it. And to see what those problems were, let's have a look a bit closer. For one thing, if I want to know how long, I can kind of fit here. If I want to know how long any one of these pieces of code takes to run, like if there's a bottleneck somewhere and I don't know what's causing it, it's not very easy for me to do that with the way that the code was set up before. I would have to manually put in timing events here and there, and that would be difficult. Very difficult, because I don't know how to do that stuff. What if I want to add in new features? If I want to plot the platform while it's moving around rather than controlling the robot, or if I want to add in the eyes, or if I want to add in, I don't know, something else, I need to manually make sure that all of these scripts and classes and everything are working together and are doing what they're supposed to be doing. And that's a fair bit of work to make sure that everything's kind of like happy talking to each other. And that would have been a bit difficult. How do I visualize what's going on? Again, with the plotting thing, so like if I want to simulate what's actually happening, I need to make a new class or a new something else that's in there. And this is what I had before in my Stewart platform inverse kinematics node. This node here, I had a plotting thing, and that would just plot. And now that I think about it, it could never plot while I was doing, it could never plot in all situations. It could only either plot or control the robot. And I had never fixed it up so that I could do both at the same time. And my version of plotting is with like matplotlib, and you'll see what this is a bit later on, but it's not a good simulation by any stretch. So that's an issue. If I want to actually simulate like collisions and to figure out what the actual, like the literal exact robot is doing rather than just some nice like lines and dots, I would not be able to do that with my own code. I'm not that good at software to do that. And if I want to debug things, if I want to know where problems are, I don't know how to do that. Like I can print things to the console, but that's not super informative. And there were multiple times when something went wrong and the O drives would just turn themselves off. And the O drives have so far been my only source of errors for like the actual hardware of the robot. And if they all turn themselves off, I can't access those errors, and I just have to turn them back on again, and then the errors are cleared. And there have been a couple times where something has gone wrong and I have literally no idea what happened, and I have no way to know that because the errors have been cleared. So that's a problem. And threading, two big question marks here, because I have been thoroughly turned off the idea of threading because it's difficult to put into practice with Python. But I like the concept of it. So the idea with threading is that if I have multiple pieces of software all doing different things, I can sort of allocate resources to each of them, and that way they can always have enough like computational power to do what they need to do, and they're not going to interfere with each other. Which is cool in theory, but I've heard that it's annoying to do in practice, so I kind of got turned off the idea, but I like the principle of having things be distributed. So that's what's wrong with what I was doing before. What is ROS? This stands for Robot Operating System. Actually, before I go too much further, this is about as much as I can say with certainty. I'm very new to ROS. I started learning ROS about a year ago, and I just got very lost in it, to be honest. I couldn't see the immediate utility of porting my project over onto ROS. It was just too much of a black box. I think part of that was that I was working also in C++ then, because I was doing things on Arduinos, and C++ is not understandable to me. It's very hard to use, in my opinion, and I just got really lost in all the CMake nonsense and everything. But in the last couple of days, I've been convinced to change over from some people who I will thank later on. And yeah, with the help of ChatGPT, things have been much, much, much easier this time around. So the reason why I say this is because take what I say here with a grain of salt. I'm going to explain my understanding of ROS, and there may be some things wrong here. If you are familiar with ROS and you notice that I say something wrong, please let me know, because that would be handy to be aware of. There is a very steep learning curve for ROS, but it is insanely powerful. I continuously am learning more and more about what ROS can do, and it is phenomenal. Typo, where's the typo? I don't see a typo. Oh, in Darkman's thing, right. Yes, the main structure of ROS consists of nodes. So we have lots of nodes, and these can all send information to each other with a couple of different means. One way that they can send it is constantly to each other. So they can just be spitting information at each other all the time. And they do this with what's called topics. And they look like this, where we have a publisher node, which is the one with the orange ellipse on it. That sends a message out to the topic, and then whatever is subscribed to that topic will receive that information. And there's all sorts of ways to make sure that this information is not lost, and if it is lost, that it can be recovered. But that's a whole separate thing. But this is the general principle, is that you can have as many nodes as you want sending information into the topic, and then that topic can send that information out to as many subscribers as it wants. There can be zero, there can be lots. It's very, very cool. Or if you don't want to be sending information constantly, you can have what are called services, where there will be one node that will request some information from another node via the service. That service node will receive the request, go, yep, cool, I'm going to send you your information out now, and then the information goes back out. So it's like a one-time thing. There are many more, well, there's at least one more type of information exchange that's available to nodes, but I'm not using that right now, and I don't want to overcomplicate things in my explanation if I don't need to. So far, I'm only using topics and services. Maybe next week we'll see actions, potentially. So this is the new structure of the same sort of thing that I had before, but now in ROS mode. So the idea is we have, the blue ones are all nodes. So we have the node that creates the path. This sends the path via the path topic out to the hand inverse kinematics, which then figures out the Stewart platform pose and publishes that to the pose topic, which then follows down the chain, blah, 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 until it gets, until it moves the robot with the can handler. However, I don't want to just implement this straight away and then have the robot move, because the robot would definitely not move in the right way and it would break immediately. So what I want to do is I want to be able to plot things. I want to be able to see what's going on here. For anyone who's familiar with ROS, just hold that thought of RViz for the moment. I'll come back to that in a bit. But yeah, I just want to see what's going on. Very simple, like basic geometry and like drawing of what's going on. So what I've done is I've made a plotting node, which can also, which does also subscribe to the Stewart platform pose topic, and then receives the exact same information that the Stewart platform node, that the inverse kinematics node receives. So both of these are subscribed to the same topic and they both get the same information out. So this way I can plot exactly what is being sent out to the inverse kinematics, which is very cool. However, oh, thank you, Daniel. However, both of these nodes, the Stewart platform and well, I'm going to call this the inverse kinematics one from now because they're all Stewart platform related. The inverse kinematics node and the plotting node both need to know the geometry of the platform. They need to know things like the radius of the platform, the radius of the base, all that sort of stuff. So what I've got is a robot geometry node that stores all that information. And then when the inverse kinematics or the plotting nodes need that information, like when they first get booted up and they can store that information themselves, they request that information via the get robot geometry service. This is the only service I have so far, and that's what that does. So yeah, actually I'll get rid of myself now. So this is the general structure of, this would like replicate what the old structure would have done. But the really neat thing about this is that I can add nodes wherever I want here. So for example, I don't really want to deal with this stuff right now. This path creator and hand inverse kinematics, this is all quite complicated. And I would prefer if I could just control the robot with like my space mouse, for example, which is, for anyone who's unaware, this thing, which is what I use for CAD. It's, yeah, you can move this puck in all sorts of different directions, and I want to be able to move the robot using that puck. So what I've got is a space mouse handler node that publishes to the Stewart platform pose topic. So I basically grab the position of this puck and then publish that to this pose. So I'm saying I want the platform to do exactly what this puck is doing. And then as far as the rest of everything else is concerned, this information, it doesn't matter where this information came from. This could have come from here, this could have come from here. It doesn't matter. But all we know is that we want the platform to be at that pose, and so it continues with everything else the same way it would have done before. Right now, I have only implemented this stuff because I haven't been doing it for very long, and I'm still just learning how to get this all set up, and it just takes time. Yeah, but so far, it's all working quite well. And I'll show you in a sec what that looks like. But I'm also thinking, in the future, I can add to this pose topic, I could add a dance pattern creator. And if you've been following this project for a little while, you might remember that I had that short of like DanceBot, where it was kind of moving around. I could do something like that, but it would be trivially easy now. I can just figure out the pattern that I wanted to do, so publish that information to the pose topic, and then the robot would do it. Before, that animation took me, sorry, that like the short video, I think took me like 2 days to figure out all of the positions of where it had to be and like get them all timed correctly. The timing was not easy, but it'll be significantly easier now, which is good. And I'm also thinking in the future I can add a GUI. So I'll have some sort of interface where I can control like the various positions of the platform and get it to move around that way. And all of these are very easy to turn on and off and to decide which ones I want to be using, because this is all set up with ROS. They all just publish to the same topic, and then that topic handles that information in exactly the same way. It's beautiful. But you might be wondering, this is fairly complicated, right? And this is only handling the Stewart platform part. This is not doing anything to do with the eyes. This is not doing anything to do with the actual juggling pattern. There's still a whole lot else that needs to go kind of like above all of this. So there's a pretty natural question in my mind, which is that, is all of this effort really worth it? Because this is ROS, yeah, as I said, ROS has a very, very steep learning curve, and it's going to take some time before I can fully implement everything that I had before into ROS. So I think it's a very valid question to ask, is this worth it? In my opinion, yes. Hands down, unequivocally, yes. For example, I can very easily time each topic. There is an inbuilt timer in ROS, and you can just ask it, how often is this topic publishing? How often is this service being called? How often do all of these different events happen? And it will just tell you. It's just like, yep, here you go. This is the information you want, with like all of the statistics you could possibly imagine that you would want. It's great. It also records your data. So if, for example, I'm in a session where I'm doing stuff with Jugglebot, and then what happened before happens, where all of the O drives just turn off for whatever reason, and I have no way to read into them to see what happened to them. Roz will record all of, if I ask her to, will record all of the information that was transmitted over that session, and then it puts it into a nice little file where I can then look at that file later on, and I can open that file up and run it in exactly the same way as it did before. And this is kind of where the RViz stuff comes in, which I'll talk about in a sec. But it makes it really easy to figure out what happened in the previous run. It's really, really handy. It's also easy to stack. And by this, I mean, if I have two Jugglebots, I can just create two instances of the Jugglebot package, and then I'll have two Jugglebots, and they can mimic each other or they can do different things. And it's just as simple as going, here's one, boop, here's another one. And it's running all the exact same code, but it's a separate instance. And I honestly have no idea how I would have done this in my previous code base. I hadn't really thought that far ahead, and yeah, I don't know how that would have worked. There's also very good error handling. So you can log messages with varying levels of severity, and you can tell it when to send these messages and when not to, and that sort of thing. And these are the different severity levels that you can give them. You can say, this is just for debugging, and then it won't come up in your console if you have set it to not show debugging. Or you can say, oh, this is pretty bad, like this shouldn't really be happening, but it's not catastrophic. And so you would give it a warning or an error. But then a fatal one would just like stop everything. And you can set those messages fairly easily. And I really, really like that, because before I had to just have like random flags in my code being like, oh, if this is happening, then kill this process. But that would only kill that one process and not the whole thing. Yeah, this is much, much nicer. You can also do physics-based simulations with RViz, and RViz is freaking amazing. It's very cool, but I have not been able to go into it because I don't know how to make a Stewart platform in a file type that is accessible to RViz. So I'll come back to this in just a sec. But with these physics-based simulations, once I do get to the point where I can use them, in my mind, this is the first big step to making an AI-controlled Jugglebot. There is a whole suite of software made by NVIDIA that is designed to basically train models, like neural network models, on moving robots around in really realistic physics simulators, and you just tell them what your objective is. I haven't used these, so this may be a bit of an oversimplification, but my understanding is that you basically just tell them what your objective is, and then they just simulate the robot like 100,000 times over the equivalent of like 10 million years, and it just learns how to do it the same way that biology learns how to move around, just by trial and error, which would be amazing. I'm very, very, very interested to see an AI-controlled Jugglebot. I think that could do some very cool things that a human-controlled Jugglebot would not be able to do. And there's a lot more that Roz can do. I am just scratching the surface of Roz, and it's super exciting. There's so much that it can do, and I'm constantly learning more about it, and it's a huge step forward for the project, as far as I'm concerned. This said, I do have some questions, especially for the people who are somewhat familiar with Roz. Actually, before we do questions, let's do a little demo. So here, I can't do me and the screen. Here I've got my Linux set up, and if I launch my launch file, this will come up. And so this is what I've got so far. I can make this bigger, hopefully. Yes. And so I can control this with the space mouse. And you can see like, as I go up, so like the purple kind of triangle in the middle is the hand, and as I go up, the hand goes up, as you would expect based on how the hand is connected to everything else. There are some weird things, like if I go down, then the hand goes down, but let's just ignore that for now. But yeah, so I can control this with my space mouse, and you got to kind of take my word for it that I'm telling this what to do in like effectively real time. I don't have my camera set up to show you both views at the same time, but it's very, very, very quick. And this is super cool. And it's very nice that this is all working properly. I'm very happy with it. So yes, I have some questions for people who are familiar with Roz. The first one is, I don't know where the best spot is to put the safety check. So previously I had basically on this the equivalent of this motor positions topic, it would essentially cut everything so that if the motors were being told to go less than 0 or more than 4.2 rotations, then truncate that to only be within those bounds. Never let that value be outside those bounds. I'm thinking of just doing the same thing now, so that like there's basically a barrier here so that if it's more than 4.2 or less than 0, it will just get throttled before going through. But I feel like there's a better spot for it, and I'm just trying to think of like where I can put where the best spot is to take that information from, and then what to do with that information. Because ultimately, if the motors are being truncated, if their positions are being truncated from what the programmer told it to do, then really that has to go back and inform the path that, hey, your path was invalid. I don't really know the best way to do that. I think I'll just put a simple one on the motor positions right now, just to stop the robot from killing itself. But I feel like there's a better way to do that. I'm not really sure. Another one is how to handle homing. So before, when I was doing all the code just like the caveman way, I I just had the homing sequence just had to be run every single time before I started. But I feel like there's some clever way to have some sort of like state machine where I can say, has the robot been homed? No. Well, if no, then don't do anything else before it has been homed. Like send out some sort of signal being like, hey, I haven't been homed yet, home me. So I don't know. Albert, the analytical solution, one person suggested one in last week's live stream, in the comments to the live stream, and the other one was in Zulip in the ARM topic on Zulip. Yeah, I haven't like collected them all or anything, and I don't know if either of them work. I haven't had time to check them out yet. Yeah, so I'm not sure how to handle the homing because I don't really know how a state machine sort of thing would work with ROS. I don't really know. I'm thinking of just doing like a basic, like just do it manually every single time. I don't really know. Yeah, another one. I'm very curious about what's going on here. So I have set down the bottom. This is where I've like set these values. And then the top is after I have received those values from like a call to that service. So we can see that when I've set, the other one's easier, the green one's easier. I set the value to be 247.8, but when I received it later, it was 247.8, blah, 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 blah. I'm very well aware that these changes are like minute. It's like way, 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 way down the decimal point line, but I'm just kind of curious why that's happened. I can't see any rhyme or reason to that. It's just very strange. I don't know. If you're familiar with that, then I'm keen to know. I'm not super worried about it, but it'd be good to know, I think. And this one's super strange. Let me get rid of myself again. So, sorry about that. So this is in the topic that is reading the space mouse controls. So we can see we're reading from the space mouse. But for some reason, I have to swap. So we've got roll here and pitch and roll. I've had to swap pitch and roll so that at least the animation does what I'm actually doing on the space mouse. Otherwise, it was rolling about the wrong axis and pitching about the wrong axis. It's very strange. And I don't know why I need these negatives here either. I did need negatives before on the yaw and the pitch. I don't really know why. It's just bizarre. Like the space mouse works fine in CAD. It does exactly what I do in CAD, but some of the axes are just like flipped in ROS. I don't know why. It's very strange. Again, I'm not super worried about it because it seems to be fixed now that I've just kind of like flipped things around, but it feels like a bit of a janky solution. And I'm a little bit thinking that it might be to do with quaternions. So I have no experience with quaternions and they kind of scare me, to be honest. But I found that there is already like a pre-made way of sending information over ROS topics that involves using quaternions. And I figured that I should probably use their pre-built message package that they've already set up and that people have been using. Like it's like industry practice, so I figured I should probably do that. So I'm just like sending the rotations over quaternions and then converting them back to Euler angles on either side. Maybe to do with that, but it's doing the right thing once I flip those two axes. So I don't know. Yes, this is so I don't know how to build a parallel robot in URDF format. from my understanding, URDF kind of relies on things being a serial robot, like our arms. Like you've got a link here, or like a joint here, and then a link, and then a joint, and then a link, and then a joint, and so on. But if you have like joint, link, joint, link, joint back down to the base, and they're connected, like what Jugglebot is, URDF doesn't really seem to like that. And if you are aware of any strategies to make a parallel robot in a URDF format, I'd highly appreciate if you could share that with me. Because if I can make a URDF Jugglebot, then I can put this into RViz, which can do all of the physics-based simulations. And that could do all of the collision checking and everything like that. And that would be amazing, because then I would not need to use my shitty little matplotlib thing anymore. And I would actually get some useful information out of my simulations. Yeah, this is one that I just discovered this morning. Well, I've been thinking about like last night and this morning. So plotting and the inverse kinematics node have a little bit of overlap. So right now, this robot geometry is just sending out the basic like radii and lengths and that sort of thing. And then both the plotting node and the inverse kinematics node are doing the same calculations to convert those geometries into the actual position of the robot. And I'm thinking, I guess my question is like, my intuition is that if I have two nodes doing the same thing with the same information, I should probably put that same thing and same information into another node that then sends that information out. I'm cautious of adding too many nodes. I don't know. Is it a problem if you have too many nodes? I don't know. Should I always stop two nodes from doing the exact same calculate? Like it's going to be literally line for line exactly the same. But I don't know. And like later, if I do RViz, I may not need this plotting one, and I might just need the inverse kinematics one, and in which case that second intermediary node would be a bit useless. It'd just be taking information, doing some calculation that the inverse kinematics could very easily do, publishing that to another topic, and then just kind of, I don't know, unneeded complexity. I don't know. Can I go back? Yes. And if anyone's aware of how to display services in RQT Graph, because there's this really cool thing in ROS, let me get rid of this, where you can have, hang on, just give me one sec. You can make this graph that will show you everything that's running on the ROS network right now. And it's really cool because you can like highlight different things. Let me see if I can make this bigger. Is it like a zoom? I don't know. Yeah, so like if I highlight like the platform pose, it's kind of hard to see. If the platform pose node is highlighted, I can see very clearly what thing is publishing to that, in this case the space mouse handler, and what thing is subscribed to that, in this case the plotter. And obviously as I add more and more to this network will get bigger and bigger, and it's really, really handy. But I can't see the services because this robot geometry thing is connected to the plotter, but it's not showing as a connection because it's only a service, like it's not running all the time. So I don't know. If there's a way to do that, I would love to know. I just had this image in case I couldn't load that. And yes, big thank you to James, Joshua, Finn, and Jean-Marc for pushing me to move over to ROS. I've known that ROS is in Jugglebot's future for a long time, and I've just been putting it off because I've been too intimidated by it. And yeah, you guys pushed me to start looking into this, and yeah, that was very good. I'm very glad that you did that because I have no regrets whatsoever. In my mind, I've just like completely removed all of the code that I was working on for the last like 3 weeks. It's just like, no, gone, doesn't matter. It's in the past. So yeah, it's very good. I'm very thankful for you. And I'm also extremely thankful for ChatGPT. ChatGPT has made this, I have learned more in the last like 3 days than I learned in the 2 weeks when I was learning it a year ago. It's unbelievable. I would also, one other thing actually, just while it's on my mind, if you are contemplating learning ROS, I cannot recommend enough having a project to actually implement it on and use ChatGPT. If you're just reading through the docs, I just cannot read through the tutorials for that long. I did like the first set of tutorials. I'm like, all right, ChatGPT, I've done the first set of tutorials. This is how much I know. Let's do some stuff. And it was like, yep, cool. I'll walk you through it. That was the perfect way to learn this, in my opinion. So have a project in mind that you want to do with ROS and just use ChatGPT. I think the first set of tutorials is good to get a rough understanding of how stuff works. But after that, ChatGPT can fill you in. At least ChatGPT 4. I pay for it because it's worth it. I can't say how good 3.5 is. And yes, for anyone who's curious, I'm using ROS to Foxy because I am using an Ubuntu 20.04 and I don't know how to use Docker yet. I have a feeling that Docker is going to be the same sort of thing that ROS and Can has been, where I'm like, yeah, it's like in my periphery of like, yeah, this is a thing that will be useful. And then 2 weeks later, it's like, oh, okay, I should make the move. So to be honest, I'll probably move over to Docker and a more recent version of ROS at some point. But for now, I'm keeping it simple, one thing at a time. Yes. And that's it. Cool. So I'm just going to check through the comments. Thank you. Yeah, I figured that the decimals is just some like error noise business. Yeah, it's good to know that it's nothing major, at least. Motor node shouldn't break the modus. Yeah, Josh, I agree with that. Each node is implementing the safety for whatever it is responsible for. Yes. But it's tricky because I don't know what the actual like workspace is that won't make it kill itself is, I think, an underlying problem beneath this. If I did know that, then yes, I agree. Because there are some orientations where like the legs just pop off and I don't know what those angles are. And it's not quite as, I wish it was just as simple as being like, yep, if you rotate by more than 45 degrees, then it's going to break. But it's not always 45 degrees, because if the platform's over here, then that angle is going to be a lot more significant than if the platform's over here, say. So I don't know what the actual workspace is. Yeah. Fox, why is the plotting node not listening to the motor positions node? Because they are plotting different things. So the motor positions is I haven't done this yet, so yeah, we'll see. But my idea is that the motor positions node would just be publishing the 6 positions of all the motors. If the plotting node were to listen to those 6 positions, then it would have to do the forward kinematics to figure out, okay, based on these positions, where is the rest of the platform going to be? And that is difficult. Forward kinematics with parallel robots, I haven't done it before, but I've read into it a little bit and it seems very difficult to do. But if I listen in before the inverse kinematics is done at all, it's the same information. It's just not being, it's just not as far down the processing chain. And you are right. Like I've actually got I've got a little piece of paper where I've been like drawing all this out, and it's a bit messy, so I won't show you, but I've got a listener node on here. This is how I've drawn my listener. So I will definitely have a listener on the motor positions, just checking that they are what I expect. And I should probably do them in like a line graph style thing so I can see them pretty easily. But the plotting one, actually, it won't be listening to that because it's a bit more complicated to do that. If you only use one, I do only use one ROS workspace. Yeah. Yeah, okay. So I've added the setup.bash for the actual, I've done that for the ROS one, but I haven't done that for the workspace one. So maybe I should do both. Yeah, you're right, because that is a bit annoying having to source it. I was so confused this morning. I've been like trying to not reboot the Linux computer for a couple of days. And just this morning there was an update and it's like, oh, to get the update, you need to reboot. I'm like, just for the live stream, is it worth it? And I did it, and then I was like, oh shit, nothing's loading again. I'm like, that's right, I have to source it, because I just did it once, like 2 days ago, and then I just left it running the whole time. So yeah, adding that would be good, because then I wouldn't need to source it every single time. Yeah. Docker just kind of works. Yeah, I've heard that, but I feel like it's the sort of thing where it just sort of works if someone sets it up for you, and if you are able to talk with someone who knows what they're doing, which, I mean, is ChatGPT now for me, so that is good. but I'd prefer to just keep it simple. And from what I'm told from people on Zulip who seem to know what they're doing, that it's fairly easy to move from non-Docker to Docker. So I'm thinking of just doing everything like this for now until I get a good handle of ROS and like everything's kind of working a little bit. And then once I want the more updated features of like the newer ROS, then I'll probably move over to a Docker so that I can use the newer ROS. That's good to know. I'm glad that ChatGPT is good with Docker. That will be very handy. Yeah, and I have been debating whether I should look into quaternions at all. I've been using ChatGPT a bit to kind of like pull me up with my quaternion knowledge. Maybe I should just spend some time to learn about them properly. Yeah. I have been looking at the articulated robots one. That has been super useful. Some people on Zulip suggested articulated robots, and I have binge watched a lot of his videos now. It's kind of like procrastinating from doing actual ROS work by watching videos about ROS. They're really good. And he's Australian as well, which is cool. Yeah. Yeah, so that's how things are going right now. I am planning on just, like for the next week or so, I'm just going to build out this ROS network to be a bit bigger. I'm glad to know that adding more nodes is not going to be a problem. I think, yeah, especially with the Jetson's quite powerful, so I think it should be fine. But yeah, lots of ROS. It's very exciting. It's very cool. I'm really liking it. ROS is a big step forward. Cool. Well, thank you very, very, very much for all of your input today. This has been very useful, and I'm very thankful for your help. And I hope you all have a very good weekend, and I'll see you next week. Till then, have a good one.